Hello, namaste, and good evening to you. Uh, this is the second part of the routing and packet forwarding, how the router basically forwards packet. In previous slides, we have looked after a router and computer similarity, and in this chapter, we are going to discuss further about how to configure devices and apply IP addresses. So let's continue with this chapter. In this chapter, we are going to study about the configure devices and apply addresses as said earlier. Basic router configuration. A basic router configuration should contain the followings. Okay, it should have a router name, its unique router name. It should at least have a banner. It should have a password. Use of a strong password is always recommendable when configuring the configuration on the router because it's very much needed for the purpose of security. Other is interface configuration. Specify interface type, either it is FEG, serial port, or IP addresses. What kind of IP addresses should we use? Should we use the private IP addresses, public IP addresses? What is the subnet corresponding subnet marks of the IP addresses? Describe the purpose of interface. Also, adding a description to the interface is always recommended, and then we will issue a no shutdown command. If DC serial interface, issue a clock rate command. Then if the router is a DC, then we should also use the clock rate. After entering in the basic configuration, the following tasks should be completed. It should verify basic configuration and router operations, save the changes on router. After making configuring the basics and router operations, we should always save the commands. So as said earlier, the naming the router, we will use the command host name and the name of the router. Similarly, for setting a password, we will use around 6 lines of command, including enable secret password, line console 0, uh, password. Uh, we set the password as a password and the login and line bty 04. Similarly, for configuring an interface, we will use a password login, interface type, and the number of which type we are using. So we will use the IP addresses and marks, and we will add description, and then we will use the no shutdown command. Similarly, for configuring the banner, we will use the command banner motd, and then what message we would like to highlight, and then we will copy the startup running configuration into a startup configuration using a copy running config startup config. So after all this, we need to check the configuration. So checking the configuration, so running config, so IP route, IP interface brief, so IP interface brief, and so interfaces. So these are the commands we will basically use to configure and apply addresses. So as discussed earlier, and so we use this so running config command. So the basic router configuration by issuing the copy running config startup config command. Additional command that will enable you to further verify router configuration are so running config, so startup config, so IP route, so interfaces, and so IP interface brief. Okay, which displays abbreviated interface configuration information. Routing table is stored in RAM and contains information about directly connected networks. This occurs when a device is connected to another router interface. Remotely connected networks, this is a network that is not directly connected to a particular router. Detailed information about the networks include source of information, network addresses, subnet marks, IP address of a next hop router. So IP route command is used to view a routing table. We will further look what how they looks like. So if you look at what they look like, which we have discussed earlier, each router interface is a member in a different network. So this interface is the member of 192.168.1.0. Similarly, this serial interface is a network of 192.168.2.0, and this fast ethernet 0/0 is a 192.168 3.0 network. Activated using a no shutdown command. After configuring the IP addresses, the interface we will activate using a no shutdown command. In order for static and dynamic routes to exist in a routing table, you must have a directly connected network. For example, if this router wants to go to the 3.0 network, then it has to first go to the directly connected networks of 192.168.2.2. So if we run the command show IP route, then we can find directly connected networks and static, or if there is a dynamic network, the dynamic routing protocol, then we will also use dynamically learned routes in the show IP route. Static route in the routing table includes the network addresses and subnet marks and IP addresses of the next hop router or exit interface, denoted with the code S in the routing table. So if static routes are configured in a router, then it will be coded with yes in the routing table. Routing table must contain directly connected networks used to connect to remote networks before static or dynamic routing can be used. So it must have a directly connected network. When to use the static routes? When a network only consists of few routers. If there is a few routers, then we can use the static routes. If there are a large number of routers, then it will be a very huge task for the network administrator. And in those cases, we will use the dynamic routes. Network is connected to internet only through one ISP. If there is a stubby network, then we can also use static routes. Static routes can also be used in hub and spoke topology. Hub and spoke topology is used on the large network. Connected and static routes. So this is directly connected network. This is directly connected network. Whereas if this router wants to go to the 3.0, we should release the command 192.168.2.0. If we should release the command to destination address through the exit interface of serial 0/0 or through the next hop IP address of 192.168.2.2, which has been mentioned here as well. So routing table structure basically consists of dynamic routing protocols, which is used to add remote networks to a routing table and also used to discover networks. Routing table protocol also discover networks are used to update and maintain routing tables. Automatic network discovery. Routers are able to discover new networks by sharing a routing table information. So in dynamic routing protocol, the routers, the networks share the routing table information through which they will update their routing table, and in that case they will have destination IP addresses, next hop IP addresses, and the exit interface as well. So maintaining a routing table. Dynamic routing table are used to share routing information with other router and to maintain and update their own routing table. IP routing protocols. Example of routing protocols include RIP, IGRP, EIGRP, and OSPF. So RIP is a distance vector routing protocol. IGRP, okay, EIGRP is an advanced distance vector routing protocol, whereas OSPF is a link state routing protocol. As you can see here, RIP, this router R1 is able to run the dynamic routing protocol, which is the RIP, as denoted here by R, has learned the routing protocol through a dynamic routing protocol. For example, if this router wants to reach to the destination 4.0, then it has to go to the next hop of 192.168.2.2 and the serial the exit interface of serial 0/0. Routing table principle. Three principles regarding routing principle. Every router makes its decision alone. This we should keep in our mind, that every router makes its decision alone based on the information it has in its routing table. Different routing table may contain different information, so this router may have a different information than this, and this may have a different information than R1 and R3. Similarly, similar the case for R3 as well. Different routing table may contain different information. Routing table can tell how to get to destination, but not how to get back. So this can tell where to go, but this cannot tell you how to return back to this R1. Effects of three routing table principles. Packets are forwarded through the network from one router to another and on hop by hop basis. So okay, packets are forwarded from this network to this network through hop by hop. Maybe it has to go to this router, again to this, and finally to this. Packets can take a YAX path to destination but return by a Y path. So this router can move to this router via this path, but can move from this path as well, or maybe from this path it can reach to its source, which is also known as asymmetric routing. Internet Protocol IP packet format contains the fields that provide information about the packet and the sending and receiving host. Fields that are important for CCNA students: destination IP address, what is destination source IP addresses, what is the version of IP address, what is the time to leave, what is the IP header length, precedence and type of service, and packet length. I hope this has been very informative to you, and I'm looking forward for your presence in another lecture. Thank you for watching. Goodbye.